Alright, so I'm going to show you guys shaders today. Now shaders, there's some really cool things you can do with shaders. So we're going to start off, there's like, you can invert the colors. You got this pane that does that. Here we've got the explosion shader that I've been working on. And here's a secondary explosion one. This one requires to be running during playtime. And it does modify the colors and such. It's a little bit more complicated, so we're not going to get into this one today. I just want to show you it. This is the one we'll probably be using for the game for now. Let's see. So when I right click, it causes those little explosions to come through, and the colors, they kind of get inverted a little bit through that inverter. But that's not the point of what we're going over today. Today we're going to talk about this shader here. So this one basically takes the vertices on the object and it wiggles them based on time and using a little bit of math and sine and cosine and such. So basically, let's go ahead and create our shader. So let's come over to the shaders folder, right click, create. We're going to do shader, and then we're going to do a surface shader, a standard surface shader. And I'm going to name it explode. Why not? New explode. New explosion. Okay, there we go. Double click, open it up. Okay, so if you're completely new to shaders, shaders are comprised of two parts. They've got the properties section and they've got the sub shader section. So the properties are what show up in the inspector itself, and the sub shader is what does the heavy lifting. So inside of the sub shader, there's what's called a C program. So I'll go ahead and select all of that. So right now, what it does is it'll just create a standard blank gray color. And we can change the color a little bit, but we don't want that for now. So we're going to go ahead and clear that out. So our shader is going to be basically everything that we're doing is going to be inside of a C program. First, let's come up to the properties, and we're going to modify the properties a little. So we'll change that to ramp texture, just so it lines up more with what we're actually going to be using. And we're going to do a ramp offset here as well. Now, the way this works is the underscore ramp offset, that's what the shader itself reads everything as, and that's what the computer reads everything as. And then we'll put in quotation marks ramp offset, and that's what will show up in the inspector itself. And then we got to define what type it is. So I like to use range, so I'm going to do a range between 0 and 1 and just set it to 0. So basically that means that it'll stay defaulted to 0. We don't need that, so we'll go ahead and just trash all that. Okay, we're going to add in a couple more things though. So let's add in a displace map. So disp map, and we'll name it, actually let's rename that one. Okay, and we'll name our displacement map the displacement map. Alright, and so a map like this is going to be a 2D. So it's a 2D because it's a picture. And we're going to have it equal, right now we're going to equal it white. Now, after a 2D, you always have to put those curly brackets. Don't really know why. I think it has to do with the way the shaders used to work. But now, you don't really worry about what's inside them. You just need to make sure that you have the curly brackets at the end. We're also going to add in a bump map. Or, I'm sorry, not a bump map. We're going to add in the displacement range. Basically, it's going to call it let's call it the amplitude. So we'll do this as, let's see, we want it to be able to go in more than it normally does. So let's see, actually, we'll just set it for now for 0 and 10. And we'll just default that to 10. Why not? Well, let's drop it down to 1 so it doesn't go crazy. Okay. So now we've got that. Let's actually rename that. There we go. Amount, just so it, matches more with what we're doing. That's the amount that it's going to be, changing. So we're also going to come in here. We're going to add a displace range, and here, actually we'll do displace speed is gonna work better for us. This will be the speed at which it like warps the image, warps the game object, I should say. We'll name it speed. We'll set that to a range of 0 and 10, why not, and set it to a default of 1. Alright, perfect. Now let's change that to -10 and 10. That way we can have it go inside and outside. Alright, now we also need it to clip and sort of disintegrate away. So let's add in a clipping range. So we'll call that clip and add it to a range. It'll do 0 and just 1. So 0 will be no clipping at all, 1 will be, or I'm sorry, 0 will be completely clipped, 1 will not be clipped at all. So we'll set that to a default of 1. So inside our C program, we got to call some things. So we're going to be using a Pragma surface Pragma surface surf, and we'll go ahead and do Lambert. That way it, Lambert thing. And we're also going to use a vertex vert. Alright, and we don't want it to take any light maps, so we'll go ahead and just say no light map. Basically what that means is it will not be affected by light. Actually, let's over here. Alright, so we've got surface surf, Lambert, vertex vert, and no light maps. So for surface surf makes it so we can affect the surface. Vertex affects the actual vertices. Now we're going to do Pragma Target 3.0. I'm not quite sure what that is, but I do know that it is needed. And now we have to reference all of the things in our properties into our C program. So instead of just a 2D, it's called a sampler 2D, and we'll do that sampler 2D ramp texture. Let's go ahead and add in our color as well. So we'll do a half color, and let's see, I'm going to add in as well. Oh, sorry, that needs to be a lowercase s. There we go. Okay. So come in here, we'll do a half, and we'll do a half ramp offset. So the reason we're doing half is because halves are smaller than a float, and we don't really need anything else. I believe halves are smaller than floats. I may be wrong on that. Okay, we'll do a half for the, actually, no, we need to do the sampler for the, sampler 2D for the displace map. And notice how the things that are in blue up top of the properties are what we're now indicating here. So we're doing half displace map. Specifically, those are what we'll be calling in into our function and what we'll be using. Display speed, and lastly amount, one more, and underscore clip range. Okay, so that's all the things we'll be importing in. So now that we've declared those, now we need to create a struct, which is kind of like a game object built into code. We're going to name it input. And structs are a little weird. You have to put a semicolon at the end of them. Open and close curly brackets, of course. Now we're going to do a float 2. This is going to be the UV for the displace map. And then we're going to come over down here and we're going to do void vert, and then we'll do in out app data underscore full v. So we're getting the full amount of information for the vertex here. So open close brackets. This one does not need a semicolon to end it. So we'll do a half disp, and that'll be our displace equals our text 2D. I'm sorry, text 2D load, LOD. And basically that converts a 2D image into like combines them into like a half or an int or a float or whatever into an integer value. So, and we'll come in here and add in our displace map is what's going to be converting in. And we do also need to come in here. Okay, so we're going to add a comma and a float 4. And a float 4, it's like a vector 4, but in C program language. We'll do dot text code. That's the text coordinates of the object. And we're doing the XY coordinates and 0 and 0. Okay, that basically, that'll then convert all those values. Actually, we're going to do dot .r. That way we get just the one value. And then we're going to create a float time equals underscore time, which is a function from C program. And we're going to do 1. C program 1. And you can do a couple different things here. We could just do underscore time, or you can do underscore time 0 or 1 or 10. We're just going to do 1 for now. We're going to times it by the displace, the disp.r, which we previously declared, and we're going to times all of that by our displace map. By our displace speed. And once we've done that, so that'll determine how fast everything is going to move. So then we're going to do a v.vertex. V is what we're pulling in through the in-out up top. v.vertex.xyz, and we're going to times equal that by v.normal. And we're going to plus that by our sine. Now this is what calculates the animation itself. So it wouldn't animate if we didn't do sine. So we're going to do sine of disp times time times underscore amount. All right. And that with a semicolon. Okay, so that's going to make it so it actually animates. Now that we have it actually animating, we also want to, render out what we're doing. So that's where we come into the surf. So from up here with the surf, we're then going to create a void surf. And we're going to call in input, which is the struct that we previously did, and we're going to call it in. And we're also going to do surface output. And give it a name of O for output. Now, because we're doing Lambert, that's why we're doing the surface output. If I were to do up here standard instead, I could then come down here and do surface output standard. But for now, we're just going to do surface output and change this back to Lambert. Okay. So, turn this into a function. There we go. All right. So here in the surf function, we'll call it, we're going to create a float 3, which is going to then name it the float 3 noise. Okay. And once we've created our float 3 noise, we're going to say equals, got to make that text, TEX, 2 capital D LOD, text 2 LOD. Actually, sorry, we're just going to use a text 2 here, which I believe does about the same thing. I'm not quite sure the difference. So disp map, and we're going to do in.uv displacement map. Okay, so that basically we're taking the in out, or from the input in, we're taking the UV displace map that we created up in the struct previously, and that's being called in from the actual surface output because it can calculate its UVs. So then we're going to create an N equals saturate. There we go. And we're going to saturate noise.r plus the ramp offset. All right, there we go. And now we got to make it so it will clip. And clipping basically is going to clip when we have a certain range on the R spectrum. So we're going to do clip minus N. So N is determining the current colors of the object. And if the current colors of the object themselves are not quite, or in R are not quite what we want, in R I mean red, are not quite what we want, we're going to go ahead and clip them out. So we're going to do a half 4C, and we do a text 2D, and this one's going to be our ramp offset. Our ramp texture. Okay, and we're going to do a float 2, and this float 2 will be N and 0.5. Alright, so we'll come down here. Perfect. Alright, so we've created all those things, but we're not really outputting anything. So we're going to do O, which is our output, dot albedo, which is the color of the object, equals C.RGB. And C is what we've declared with the ramp texture, determined by the float. Alright, and then we're going to do E.emission, so it kind of looks like it's glowing a little bit, equals C.RGB as well. So emission's literally just added addition. So we're going to do C.RGB times C.A, just so that, you know, if there's alpha on the page, then it won't actually do anything. So then we're going to come out here. And let's modify this albedo so that it's inputting from our color. So let's come back into our inspector. Alright, and let's create a sphere. And we'll scroll in, scale that up a little bit. Okay. So now, in order to get this to work, we're going to, see how we've got that error? Unexpected. Alright. So come in here, what are we expecting? Oh, forgot one of those. My apologies. Alright, let's come back over here. Alright, looks like we do still have an error telling us that we have one too many of these. Alright, so let's see what I'm doing wrong here. Let's go ahead and move this line down one. We're going to do a second pragma. So delete that out, leave the note light map, but then we're going to do hashtag pragma or pound pragma, and it's going to be vertex vert. So it does the same thing, just on a second line. That's usually how I do it. I want to do two different separate lines. So let's change it to that, see if that's what's causing our issue. Let's see, let's change our surface output to surf. There we go. Alright, so the surface output issue has to be lowercase. So we're going to create a material, and see, now our material, we've got the ramp offset, and they're all sliders. So we'll come back in here. They're sliders because we called them range. So a range of 0 through 10 in our disk speed. So if we did it as a float instead, I'll come back over here. So now the bar is gone, but instead we can just grab the word float and just scale it by pulling left and right. I prefer to do ranges just because ranges are fun, and they add a little bit of limitation so things don't go super crazy. Okay, so we've got that shader on there. Let's go ahead and come back in here. So our default material is currently on that object. So let's throw on our object. Okay, so now it's pure white. That's because we're adding the alpha of nothing, and it's just super white. So all the colors that are going off of it are the color itself. Alright, so let's come back in here, So for the ramp texture, we could theoretically do any texture we want. We could throw in, for example, this texture. I'm sorry. So before I do that, we've got these super funky textures. We've got these displacement offsets here. Apparently my computer does not like these. So basically we've got a displacement map, and the displacement map determines where things are going to be changed by. And the way I did the displacement map is you do 3 different noises and you combine each one onto a different layer. So if I throw that on here, you can't see me throwing it on because the TeamViewer is open and I didn't realize it at the time. It won't go away. So yeah, so it shows up as white, but it's all displaced. Now if we want it to be displaced differently, we can change the speed, and that'll make it so that it'll actively displace. And we can change the amplitude, so depending upon how much we want it to look like it's distorting and accelerating. And then let's come back in here, let's change that out. See, now we got a different one. Let's throw on a texture. So we've got a fun little texture there. Now that's not really the point of this exercise. And we did say that we want specifically a ramp. So we'll take this ramp here and we'll throw that on. And see how it sort of displaces like that. It doesn't look super good, and that's because the wrong displacement map's on there. So if we throw a good displacement map on, suddenly we've got this. And we can crank that down to 0 amplitude or 0 speed and clip that. See how it just sort of fades away dependent on the color of the object. So that's what we want. And basically, the way this would work in the game is we would have the ramp offset go towards it, like go forward. The ramp offset's going to fade it out and see how it gets white. But we'd want to clip it before it gets white. Alright. I'm going to change up the amplitude and the speed a little. And there's the shader. And you can obviously go through and tweak these things quite a bit. Just sort of have it fade out and fade in. Okay, and if we want to add some different things to here, we've got this running as opaque. We could instead have it run as transparent. Now it's going to change the render queue here. You can't actually see the render queue again, but on yours you can see the render queue. So transparent changes the render queue. Basically, for things you want to be on top, displayed on top, you have them rendered later. So the higher the render queue number is, the more on top they will be. Now, you could make things always on top by doing 999999. The easier way to do that is, that's not the easiest way or the best way to do that. I'll explain later how to do that. Now, if we want to assign it, it's under custom. The reason it's under custom is because that's what we did at the very top of the shader where we did custom and new explosion. So if I do that, we'll come down here and test. Now it's under there. Makes it nice and easy for our use. Some other things that you can find in here is you can do what's called a header. So we're going to add in a header. These are just aesthetic things that I like to do because they make it a little bit easier to read. So add in this header, and then we'll just do words. Why not? So we save that, come back in here, and now, right there, words in bold, and it adds a little space. But we want it to be separated out a little bit more, so let's add in space. Let's say 10. Let's say 100. Why not? We'll make it super big space. See how I got that nasty big space? That's not very good, so let's drop that down to 10. That looks pretty good. I like that. So we'll leave that there, and that's the shader there. Now we could go ahead and change the time. So if we come back here, change the time. Now it doesn't really move a whole lot. So let's change that to time 3. And it's going to move a little bit quicker. Let's see, some other things that you can modify in here. Instead of sine, you could do cosine. Oh. I'm not sure why cosine is not working. Okay, so if you'll notice when you get too close, it just sort of disappears. That's because it's culling the backside. And if we fade this out a little, it's culling the back end. Now, if we don't want that, there is a way to get around that. So above the C program, inside the subshader, you do cull off. Lowercase f's. There we go. Capital O. And now, if you'll see, the back ends of everything are no longer being culled. They're no longer being deleted. If we do want to do just the backs, we could do cull front. And so now we can only see things that are not facing towards us. Basically, it's culling all the front ends of the normals instead of the back ends. And we can type in back if we want, but really that's the standard. It automatically will do that for us, so we don't actually have to do that if we don't want to. It's just sort of unnecessary. Alright, there's the shader. Now, this works just as if you... Okay, so once again, we're going to go over... Okay, so if we cover it up, it disappears. But we don't want it to disappear. Let's say we want the explosion on at all times. So we're going to do what's called Z-test. Z-test and Z-test it to always. And Z-test always makes it so it's literally always on top, no matter what. You see it. Now, Z-test has a couple different functions. We could also do ZL equal. ZL equal is pretty cool. Or, I'm sorry, ZL equal is the standard. It's basic. That's what it normally does without you telling it to do anything. Z greater, Z... Oh, G equal. Sorry. G equal. There we go. It doesn't show up there, but whenever it's behind most things, like this for example, it'll show up. But it only shows up when it's behind things now, which is pretty cool. We could use that, for example, for like an outline. Like you want the creature to have an outline, but only when it goes behind something. Alright, so that's that there. Now it looks like we got another one over here that I created a while back. So let me go ahead and grab that object. And I don't think that they will show each other. Like that one is also only showing up behind things. To my knowledge, it makes it, yeah, anyway. So let's go ahead and get rid of that because we don't want our explosion to be visible only behind things. We want it to be visible in a normal sort of way. And let's say we want to do multiple shaders, or we want it to do multiple things. We can basically, since this is a surface, we can just stack them up basically. We'll do a C program and a C program under it. That's not the best practice, and it doesn't always work super well, especially with rendering orders. You can't do a transparency and a non-transparency render. However, if you'll notice, now we've got two different renders going on. You can't really see that though, so let me hop back over to the code itself, because even when it's faded out, you can't really tell that there's two of them there. So let's come back into the code. Yeah, let's come back into our code. Set that to a stop so it doesn't move. And we'll come down to our second C program and just delete that out. See, and it doesn't really change a whole lot because C program's invisible. So we'll add that back in. Again, doesn't really change a whole lot. So let's change some stuff in the code itself so that it's doing things a little bit differently from the apparent. For example, what we can do is we can come into the displace map. I'll just do ×2. Oh, doesn't like that. Okay, yeah, can't do a ×4. Let's do... let's crank it up in the vertex movements. There we go. Okay, so we changed the vertex movement. So now, as you see, there's like 2 layers. And basically, we're rendering the object twice. That's the reason why. We've got 2 C programs, so the rendering is happening twice for each BERT. So the surface object's getting rendered twice. Now, that's a great way to do multiple pass shaders, like having a shader with an outline. That's a very good example of when you would want to do that. For this explosion, we probably don't want that for now, so we'll go ahead and just leave it as a single pass, and clear that. There we go. Alright, yeah, that's everything. You have now learned how to create a simple shader.